an integrated proposal with the same title here. So we want to know why and how the Chihshang fault creeps. And here shows the pictures of the working group, and that actually was taken in 2017. So several of you may be missing here. Don't blame me on that, okay? This is one of the rare pictures we have for this working group. We submitted the proposal twice, 2 times, but although we didn't get the funding for this integrated project, but the follow-up activities including organizing AGU sessions and having special issues in JGR says that it's actually very important to have continuous discussion and the interaction between people who have common interest in this particular form. So that's why we are here, right? We are here to share what we see and to learn what we don't see. So bear with me for another few minutes. Let me briefly show you where we were and what to expect for today. All right. This is the previous working table that we had for this working group. So in order to know where fault creeps, is it a logical boundary that allows the fault to creep? Or do we need a specific physical condition like fluid content or other specific frictional properties that allows the fault to creep? And to understand that, water table evolution gives you the permeability. That only confined into the very near surface layer, so you have to go deeper, right? To go deeper, you can get the rock sample from as deep as where you can extract the rock. So the microstructure, composition, and frictional properties of the rock can be learned from laboratory experiments. But that only goes down to 1 kilometer. And to go deeper, you also need the resistivity studies, reflection and refraction maps to compare with the velocity structure so that we can actually go down to the bottoms of the seismogenic zone. It's about 30 kilometers for the Chihshang fault. However, every component we have kind of long-term study already, but the investigation sites do not overlap oftentimes, and their resolution also doesn't meet our need. So that's why that's where the geodetic and seismological data can help. So to see the deep creep behavior, of course we can use the permanent station, GPS and seismic station that allows us to do better inversion. So for a good enough full model, you are able to see the creep rate, how does the creep rate change in space and time. And to do that, you need to have a comparable data from geodetic and the seismic data to tell the same story. So combining all of them for left-hand side part, tell you the physical property from shallow to deeper part of the Chihshang fault. For the right-hand side, you have data that give you the constraint of the aseismic slip behavior. And combining all of them, we are able to tell the spatial extent of the aseismic slip and to tell their time evolution. And for today, we only cover several parts of these elements as shown by this yellow box. And the number on the top of the box indicates the permutation order. Although I'm not really clear, which component actually been covered by speaker, but presumably that is my expectation. Right? So we wasn't be able to invite Guochen to tell us this, but he's here, so we can always ask him about his result for now. And so we'll have Chihshang as the first presenter to show us the general understandings of the Chihshang fault, especially from the very shallow measurements. And of course, I believe Chihshang will also cover the inversion model that tells us a creep behavior at depth as well. And the second presentation will be given by me. I will mainly talk about the deep creep rate constrained by repeating data. And the third presentation given by Yaru. Well, I think she will not only cover the geodetic measurement, but also the seismicity, but mainly focusing on the seismologic behavior revealed from geodetic data. And that is the morning session. And basically, we do not accept the question during the talk or briefly after talk, but when you have questions, we'll give you the QR code later. Okay, I'll show you in the next slide. So the schedule for the morning is, okay, we will go through the presentations, but we have maybe more than half-hour discussion time, and that is the time that the speaker will torture speakers, like they have to stand here one by one, and we'll ask them to answer some of the questions submitted by you. So of course, if you have a random question that you really like to ask during the discussion time, that also work, but we have to limit the time, into half hour, just in case that everybody is hungry at that time. So that's the morning. And in the afternoon, we have 5 presentations, and that presentations will cover from laboratory experiments that will be given by Wenjie, and the next will be given by Owen. But based on Owen, is Owen here yet? Yes, so he said he will have his student doing this presentation for him, since this is mainly his student's work. So that is the second presentation for the afternoon. And the third presentation will be given by Alex, right? Yeah, he's mainly talking about the interaction between seismic and aseismic behavior. And the very last presentation is very special because this person is not here. He's in France. So we asked him to record his video clip so that we can play his video clip. Okay, he prepared very, very hard, so we just give him time to show his result. His result is about earthquake swarm, especially in the Chihshang fault. And that will allow us to come back to the fault model. Where is creeping? Where is rock? And do all of this integrated data tell us something more?